Hello students, welcome to my YouTube channels. Today I am going to solve shear force and bending moment diagram for the simply supported beam and given diagrams will be there. So find the shear force and bending moment diagram shown in the figure in simply supported beam with overhang. Simply supported beam with overhang. Why overhang? Because support is A and B and both sides will be overhang. So simply supported beam with overhang. Both side beam you can add here with both side overhang. Both side will be overhang. C to A overhang, B to D overhangs. Okay. So now we are going to solve this question. So before this we'll find the support reactions. Always we have to find the support reaction. So what is the solutions? How will we start here? See. So find the support reactions na. Equilibrium equations, two equilibrium equations will use here. Sigma FB, total horizontal and vertical force will be 0. That means we are already discussed lot of times. Total upward force equal to total downward force will assume. This will assume here. Sign conventions like total upward is equal to total downward force. So negative positive will not write. So what is total upward force? RA plus RB. RA plus RB upward force. What is downward force? 2 point load, 1 UDL. So 10 plus, this will convert into load. So 1 into 10. UDL load plus 10. So RA plus RB upward force. So this one equation is over. Now we will take moment about A will be 0. That means here we will see total clockwise is equal to total anti-clockwise. We will calculate this. And another things what we are seeing here, if we'll take the middle point of here, 5, middle point just we'll see here, if we'll take the middle point at 5, 10 meter, no, this is length is 10 meter. If we'll take the middle point at 5, so this will be the symmetrical. This beam itself and load itself will be symmetrical. 10 is there, 1.25 is symmetrical. So symmetrical means directly we can find the RB also will come. How much RA will come? So RB also will come same. So but I will calculate and see here. So how we'll take the moment about first we'll see na. Okay. So see this moment how we'll calculate. At point A. So clockwise, this is coming anti-clockwise. So what we'll write here? And this is coming anti-clockwise. So we'll write here 10 into 1.25 this side. Then taking moment out A, you take this clockwise. What is clockwise? 1 into 10 by 2 plus clockwise. Then 10 into 11.25, 10 into 11.25 is equal to this, no, 10 into 1.25 because this is anti-clockwise. ACW, this is clockwise. At A, clockwise UDL, 1 into 10 into 5 by 2, 10 by 2, then this 10, force into perpendicular distance, 10 plus 1, 11.25. Okay. Then this is clockwise. Then RB will go also anti-clockwise. So here rate RB into total distance is 10. So here if you RB you will calculate, it will come 15 kilonewton. So RB will come 15 kilonewton. RB will come 15 kilonewton. Then RA will come here how much? RA is equal to 10 plus 10 plus 10, 30. 30 minus 15, so 15 kilonewton. So what I am trying to say here, generally like this beam will not get, but suppose you are getting, well, luckily symmetrical beam. If you will take the middle point, 10 plus 1, 11.25. RB, RA how much will come here? See here, 10 plus 10 plus 10, 30. 30 divided by 2 na 15, so 15. And also calculator also got the 15. So RA and RB we got the 15. Due to the symmetrical axis you can calculate only this. and divide by 2 because symmetrical axis. Or you check it this, see 15 is coming now, so 15, okay. So support reactions over. Now I draw the shear force 0 line here and we'll find the shear force calculation and we'll substitute this value. So shear force diagram calculation. So shear force, before this no sign conventions I am writing here itself, okay. So this is the section. If you'll see the downward force, positive, right side. If you'll take left side, upward force, positive. Now this is the section. If you'll go upward force, negative in right side, then downward force, left side will be negative. So this is the sign conventions for shear force diagram. That only will assume. So sign conventions are our ways only. So I assume downward force R will be positive. So this way we can find the shear force diagram. Now look here, FC. Shear force FC, or we are taking SA, no? Shear force na SA symbol I am taking, SC. SC. Now see, in this SC, what is the shear force diagram? Left side downward force negative, so minus 10 kilonewton. Now SA, so minus 10 plus 15. This RA is equal to 15, no? RB also equal to 15, we got it. So SA is equal to minus 10 up to this C2A and plus 15. So plus 5 kilonewton layer करते ना kilonewton. So SA I got it. Now we'll go the SB. Shear force at point B. Shear force point B. So here in the B point, UDL is there and RB vertical force also is there. So what we'll do here? We are taking left side. So before this the left, SBL. SBL meaning is this RB will not come. So how much this here? Before this, how much shear force will be there here? Plus 5. SBL is equal to plus 5. And downward force, negative. So this downward force, what is coming? UDL. 1 into 10. This load will be 1 into 10. So 1 into 10, it will coming 10. So minus 5 kilonewton will come for SBL. Now SBR. So minus 5. Then this RB. This RB is going upward. Upward left side will be positive. So plus 15. Plus 15 is equal to 10 kilonewton. 10 kilonewton for SBR. Now SD. SD how much will come? 10 minus 10 equal to 0. So this is the shear force, we got it. This is the shear force, we got it. Okay. Now we'll write this. In the diagram we'll draw. First SA 10 negative, so it will come downward. It will come downward. This line and all. So this is 10. Then in between C and A, no load. So will be the horizontal line. Point load ke horizontal line will be there. Okay, this is the 10. Point is C. Now at point A plus 5, it will go the vertical line plus 5. So this point A 5 kilonewton. So kilonewton, right? Newton or kilonewton are not, no problem. Now at point B you have to check. At point B. At point B minus 5 and SBR will be 10. So it will go. So first minus 5 will draw. See here. From this it will come. See, scales are not sufficient here. So we'll draw the inclined line up to this here. Middle. This is 5. Now look here. This will be up to L. SBL minus 5. SBR, that means point load is acting. So how much this is going? Plus 10. So it will go up to 10. This point is B. This point also B, but this minus coming where? Where this point load RB not acting. That's why we are writing SBL. SBL means just before this reaction point. And SBR utilize this RB reaction force also. So see this minus 5 to 10, minus 5 to 10 in this point. Now last one, what is there? SD will be 0. SB will be 0. So draw the, because point load is there, draw the horizontal line and draw this, because SB will be 0. So this is the shear force diagram. This is the shear force diagram for us. Okay, so draw this line now, it will be looks where will be our shear force diagram. This point is D, this point is B, this point, suppose you take some point M. If you take the shear force at M, see how much will come. Just we check it. Shear force at M. Shear force at M, how much will come? Minus 10. Shear force at M. Oh, why will calculate shear force at M? Bending moment will see. So this is why the shear force diagrams over. Shear force will be M is not given a point, no. So now we'll go the bending moment diagram calculation. So bending moment diagram calculations में SC and MC. MC equal to 0 is equal to MD will be 0 only. This bending moment about C about D will be 0. MC and MD will be 0. So we'll calculate the bending moment at A. So MA, that is called bending moment at A. So its sign conventions will follow again here. So draw one sections here. If we'll do the clockwise, negative. If we'll do the anti-clockwise, ACW, this is right side, this is left side. Then draw the bottom, this is clockwise, this is anti-clockwise, positive, and this is clockwise will be the positive. So this is the, we draw the sign conventions for bending moment, because without sign conventions we cannot. So what sign conventions we follow, that sign conventions only we have to do the calculation part for that sign convention. You can assume reverse also, nothing wrong. So you follow any one. So what I follow, this is the simplest one. This also middle point you draw here. Middle point also, this line, if you project a small line or pencil or 2H pencil, it will be okay. So now we'll draw the 0 bending moment line. 0 bending moment line. This, in this line bending moment will be 0. Like this here, shear force blue color, no? This line is shear force diagram will be 0 line. So you can write here shear force diagram line. This bending moment diagram, like you can write bending moment diagram. So now we'll calculate first MA. MA now, see this C, what is going clockwise, left side will be negative. So minus 10 into 1.25. How much it will come? Minus 10 into 1. So 12.5. So minus 12.5 kilonewton meter. So how we are taking bending moment diagram at A? So C, this is coming clockwise. C, the anti-clockwise. So left side anti-clockwise negative, left side anti-clockwise negative. So moment will be 10 into this. Now we'll take the bending moment at direct B. Bending moment at B. Bending moment diagram at B will calculate. So look here, this point. Now 10 into, again negative. So minus 10 into, how much, what is the distance? 10 plus 1. 11.25. 11.25. plus now 15 RA which is clockwise positive. So what will come here? 15 into 10. 15 into 10. Then again UDL at point B. So it is coming again anti-clockwise. So minus 1 into 10 is load. Then half distance will be 10 by 2. Half distance will be 10 by 2 because UDL is connected, so no length required. So this if you calculate, it will come the bending moment at B. Bending moment at B. So 10 into 11.25 plus 15 into 2 minus 1 into 10. 1 into 10, 10 by 2. So this calculations is coming minus 12.5 kilonewton. This also coming 12.5 kilonewton. Minus 12.5 kilonewton. So MA and MB bending moment, because due to symmetrical, this coming same value. Now we'll calculate the bending moment at M. You see what is coming. Bending moment at M will calculate now what is coming. Already our overwork M, this point no, but for bending moment for M, so this point I have taken M. So what is their bending moment? So again minus 10 into this is 5 plus 6.25 plus 15 into 5 minus 1 into 5 into 5 by 2. 5 by 2. So this how much with calculations will come? 10 into 6.5, 15 into 5, 1 into 5. So it will come 0. It will come 0. If we will calculate, this is coming bending moment 0. Now we will draw the diagram. So first calculation is minus 12.5 now. So here point load now you have to draw the inclined line up to how much? MA 12.5. So we will draw the inclined line here at point A. So this value is minus 12.5. So you can write here 12.5 in this point. Okay, next MB. So this point is 0, no? This point is 0. But here having UDL. So once UDL will be there, line will be the curve line. Point load will be there. Then this is the inclined line. So point load na inclined line. Now we'll draw the UDL here. First up to this 0. So draw the curve line up to 0. So it not looks curve line. First you draw the curve line, then it will be easy for to draw the diagram. So first the curve line. Not coming. Curve line. Now this join. This is the inclined line for us, our 12.5. This is bending moment 0. Now these things I'll write. So UDL na curve line. Okay. Now what is their MB? MM. This is point M. Now MB. MB what is? Again 12.5. So you come the negative again 12.5 here. That also inclined line. 12.5. Then what is there? This moment 0. So bending moment will be 0. So draw the line, this one. Draw this line. So this is B, this is D. This is B, this is D. So what we saw here? This point is C, this point is A, this point is M, this point is B, this point is C. Look here. Bending moment at A will be negative. So we draw the diagram negative side. Now bending moment at B will be negative. 12.5 because this symmetrical axis, no? So this and this part will come same. Now bending moment at M will be 0. So this will be touch here. This will be touched here. And bending moment at D 0. So join this line. This is the bending moment diagram. So this way we can calculate this. Luckily by the symmetrical axis na diagrams will looks like this. Okay. So okay students, watch this video. beginning to end, solve this, understand and solve, and subscribe the channel, share this video to your friends so they can get the benefit. Okay, thank you.